Welcome back to my fifth video of Chapter 1 Standard 10 Mathematics NCERT textbook. In the last video, we discussed the proof of root 2 is irrational. And in this video, we can see the proof of root 3 is irrational and root 5 is irrational. Also, we can see more examples and exercises. We can see example root 3 is irrational. To prove root 3 is irrational, first we assume the contrary that root 3 is rational. Assume the contrary root 3 is rational. Then root 3 can be expressed in the form sum r by s, where r and s are integers, s not equal to 0. This is from the definition of rational number. Since root 3 is rational, we can write it in the form r by s. Now, if r and s have some common factor other than 1, divide by that common factor to get root 3 is equal to a by b. With a and b have only 1 as common factor, or HCF of a and b equal to 1. And this is called co-primes. A and b are co-primes. Now take co-primes a and b such that root 3 is equal to a by b. Now root 3 is equal to a by b means taking b to the side we get root 3 into b is equal to a. Squaring on both sides we get 3b square is equal to a square, which means that 3 divides a square. 3 divides a square. But by the previous theorem, if here 3 is a prime, if p divides a square, then p divides a. Therefore, 3 divides a. 3 divides a means a can be expressed as 3 into some number. Therefore, a equal to 3 into c for some integer c. Now substitute this a to this equation. Implies 3b square is equal to, instead of a square, 3c the whole square, which is equal to 9c square, which is, here 3 is common, implies b square is equal to 3c square. B square is equal to 3c square means that 3 divides b square. Then we get 3 divides b square. Again, 3 is a prime and 3 divides b square. Therefore, by previous theorem, we get that 3 divides b. Now see, here we get 3 divides a and 3 divides b. That is, 3 is a common factor of a and b. But we take a and b as the only common factor is 1. This is a contradiction to the fact that a and b are co-primes. This contradiction is due to our false assumption that root 3 is rational. Hence, root 3 is irrational. I will write the proof in detail. See the solution. We have to prove root 3 is irrational. Let us assume to the contrary that root 3 is rational. Then root 3 is equal to some r by s, where s not equal to 0, r and s are integers. Suppose r and s have a common factor other than 1. Then we can divide by the common factor to get root 3 is equal to a by b, where a and b are co-primes. So a equal to b into root 3. Squaring we get a square is equal to 3 into b square. A square is equal to 3 into b square means 3 divides a square. 3 divides a square and 3 is a prime. Then by previous theorem we get 3 divides a. Therefore 3 divides a by theorem. 3 divides a means we can write a is equal to 3 into some c. So we can write a is equal to 3 into c. Now substituting a equal to 3c in a square is equal to 3b square, we get 9c square is equal to 3b square, which is 3c square is equal to b square. Implies 3 divides b square. Therefore, again by previous theorem, 3 divides b. See, here we get 3 divides a and 3 divides b. Therefore, a and b have at least 3 has a factor, which is a contradiction to our assumption that a and b are co-primes. This contradiction is due to our false assumption root 3 is rational, hence root 3 is irrational. Therefore, A and B have at least 3 as a common factor. But this contradicts the fact that A and B are co-prime. This contradiction arises because our incorrect assumption that root 3 is rational. So we conclude that root 3 is irrational. We can see another example. Show that 5 minus root 3 is irrational. Clearly 5 minus root 3 is irrational because 5 is a rational and root 3 is irrational. You already studied in your 9th standard that some more difference of a rational number and an irrational number is irrational. Also, product and a quotient of a rational number and an irrational number is irrational. But here we can see this proof using root 3 is irrational. This solution is very simple since we know root 3 is irrational. Here, show that 5 minus root 3 is irrational. We assume the contrary that 5 minus root 3 is rational. Assume the contrary, 5 minus root 3 is rational. 5 minus root 3 is rational means we can find some r and s such that r and s are integers and s not equal to 0 with 5 minus root 3 is equal to r by s. Again, if it has a common factor, divide by that common factor to get a co-primes A and B. Here we can directly write that step. 5 minus root 3 is equal to A by B, where A and B are co-primes. A, B are co-primes, or A and B are numbers with the HCF of AB is equal to 1. Now, by rearranging, we get 5 minus A by B equal to root 3. Just taking A by B to the side and root 3 to the other side. Now 5 minus A by B is 5B minus A by B equal to root 3. Now B is an integer, A is an integer. Therefore 5B minus A is an integer. Here B is non-zero. Therefore, which is of the form P by Q, Q not equal to 0, P and Q are integers. Therefore, we get root 3 is a rational, which is a contradiction to the fact that root 3 is irrational. This contradiction is due to our false assumption that 5 minus root 3 is rational. Hence, 5 minus root 3 is irrational. We can see the proof in detail. Solution. Let us assume to the contrary that 5 minus root 3 is rational. That is, we can find co-prime A and B with B not equal to 0 such that 5 minus root 3 is equal to A by B. Since this is rational, we can find co-primes A and B with B not equal to 0. This is 5 minus A by B equal to root 3. Just taking A by B to the side and root 3 to the side, which is 5B minus A by B equal to root 3. Since A and B are integers, we get 5 minus A by B is a rational, and so root 3 is rational, which is a contradiction. But this contradicts the fact that root 3 is irrational. This contradiction is due to our wrong assumption that 5 minus root 3 is rational. So we conclude that 5 minus root 3 is irrational. Next example, show that 3 root 2 is irrational. This is also very simple. We can assume the contrary that 3 root 2 is rational. Assume the contrary. 3 root 2 is rational. If 3 root 2 is rational, we can find co-primes A and B such that 3 root 2 is equal to A by B, B not equal to 0. That is 3 root 2 is equal to A by B, B not equal to 0, A and B are co-primes. Now taking 3 to the side, we get root 2 is equal to A by 3B. Clearly, A is an integer, B is an integer and B not equal to 0. Therefore, also 3 is an integer. Therefore, A by 3B is a rational. implies root 2 is rational, which is a contradiction to the fact that root 2 is irrational. This contradiction is due to our false assumption that 3 root 2 is rational. Therefore, 3 root 2 is irrational. See the solution. Assume the contrary that 3 root 2 is rational. That is, we can find coprimes a and b with b not equal to 0 such that 3 root 2 is equal to a by b. Since 3 root 2 is rational, we can find a and b such that 3 root 2 is equal to a by b. A and b are coprimes. Rearranging, we get root 2 is equal to a by 3b. Since 3a, b are integers, a by b 3 is rational. And so root 2 is rational. But this contradicts the fact that root 2 is irrational. We already proved that root 2 is irrational. Hence 3 root 2 is irrational. This contradiction arisen due to our false assumption that 3 root 2 is rational. Therefore, 3 root 2 is irrational. Next, we can move on to the exercises. First question, prove that root 5 is irrational. We can see the proof. Proof is similar as in the case of root 2 and root 3. See, assume the contrary that root 5 is rational. Assume the contrary, root 5 is rational. If root 5 is rational, we can find coprimes a and b such that root 5 is equal to a by b. Then root 5 is equal to a by b, where a and b are coprime. Also b not equal to 0. Now root 5 is equal to a by b means b into root 5 is equal to a. Squaring, we get 5b square is equal to a square, which means 5 divides a square. Here 5 is a prime and 5 divides a square. Therefore, by theorem, if p is a prime and p divides a square, then p divides a, we get 5 divides a. You have to state that theorem here. 5 divides a. Now, 5 divides a means a can be expressed as some 5 into c. Now, substitute this a in this equation. Then we get 5b square is equal to 5c the whole square. Instead of a, 5c. 5c the whole square is 25c square. This is b square is equal to 5c square. 5 is common. Now, b square is equal to 5c square means 5 divides b square. Again, 5 is a prime and 5 divides b square. Implies 5 divides b by that theorem. Now, we get 5 divides a and 5 divides b. That is, 5 is a common factor of a and b. But a and b are coprime. The only common factor is 1. This is a contradiction to a fact that a and b are coprimes. This contradiction arises due to our false assumption that root 5 is rational. Therefore, root 5 is irrational. See the solution. Assume the contrary that root 5 is irrational. Then we can find coprimes a and b with b not equal to 0 such that root 5 is equal to a by b. This is nothing but b into root 5 is equal to a. Squaring, we get 5b square is equal to a square. 5b square is equal to a square means 5 divides a square. Therefore, by that theorem, 5 divides a. You state that theorem here. 5 divides a square implies 5 divides a. That is, 5 divides a means a can be expressed as 5 into some c. That is, a equal to 5 into c. Now, substituting a here, we get substituting a, we get 5b square is equal to, instead of a 5c the whole square, 25c square, which is b square is equal to 5c square. that is 5 divides b square. Again 5 is a prime, therefore 5 divides b. Hence 5 divides b. We get 5 divides a and 5 divides b. Therefore a and b have at least one common factor 5. Therefore a and b have at least 5 as a common factor, which is a contradiction. Contradict to the fact that a and b are co-prime. This is due to our false assumption that root 5 is rational. Hence root 5 is irrational. Next question. Prove that 3 plus 2 root 5 is irrational. We can prove this using the fact that root 5 is irrational. As usual, assume the contrary that 3 plus 2 root 5 is rational. Assume contrary that 3 plus 2 root 5 is rational. If 3 plus 2 root 5 is rational, we can find coprimes a and b with b not equal to 0 such that 3 plus 2 root 5 is equal to a by b. A and b are coprime, also b not equal to 0. Rearranging, we get 2 root 5 is equal to a by b minus 3, taking 3 to the side, which is equal to a minus 3b by b. Or we can say root 5 is equal to a minus 3b by 2b, taking to the side. Here a is an integer, 3 is an integer, b is an integer, also b not equal to 0. Here numerator is an integer, denominator is a non-zero integer, therefore this is a rational number. That is root 5 is rational. But this is a contradiction to the fact that root 5 is irrational. This contradiction is due to our false assumption, hence 3 plus 2 root 5 is irrational. See the solution. Assume the contrary that 3 plus 2 root 5 is rational. Then we can find coprimes a and b with b not equal to 0 such that 3 plus 2 root 5 is equal to a by b. Rearranging, we get 2 root 5 is equal to a by b minus 3, which is a minus 3b by b. Or root 5 is equal to, taking to this side, a minus 3b by 2b. Since a, b, 2 are integers, we get root 5 is rational. Rational numbers are p by q4, which contradict the fact that root 5 is irrational. This is due to our false assumption that 3 plus 2 root 5 is rational. Hence, we get 3 plus 2 root 5 is irrational. Hence, we can conclude that 3 plus 2 root 5 is irrational. Next question. Prove that the following are irrational. First one, 1 by root 2. Second one, 7 into root 5. Third one, 6 plus root 2. See solution. First one, we have to prove that 1 by root 2 is irrational. To prove 1 by root 2 is irrational, assume the contrary, 1 by root 2 is rational. That is, there exist coprimes a and b with b not equal to 0 such that 1 by root 2 is equal to a by b, which implies root 2 is equal to b by a. Since a by b is a rational, b by a is also a rational. B by a is a rational since a by b is rational. B by a is rational means root 2 is rational. This is a contradiction to the fact that root 2 is irrational. A contradiction to root 2 is irrational. This contradiction is due to our false assumption that 1 by root 2 is rational. Hence, we get 1 by root 2 is irrational. Second one, to prove 7 root 5 is irrational, we assume the contrary that 7 into root 5 is rational. Assume the contrary. 7 into root 5 is rational. Then we can find coprimes A and B with B not equal to 0 such that 7 into root 5 is equal to A by B. Then there exists coprime AB with B not equal to 0 such that 7 into root 5 is equal to A by B, which means root 5 is equal to A by 7 into B, taking 7 to the side. Now A, 7, B are integers, therefore we get A by 7B is a rational, that is root 5 is rational. Since A, B, 7 are integers, root 5 is rational, which is a contradiction to the fact that root 5 is irrational. A contradiction to root 5 is irrational. This contradiction is due to our false assumption that 7 into root 5 is rational. Hence, we can say that 7 into root 5 is irrational. Last one, to prove 6 plus root 2 is irrational, assume the contrary. 6 plus root 2 is rational. Then we can find coprimes A and B with B not equal to 0 such that 6 plus root 2 is equal to A by B. There exists coprime A and B with B not equal to 0 such that 6 plus root 2 is equal to A by B, which means root 2 is equal to A by B minus 6, which is A minus 6B by B. Since A, 6B are rational, we can say, since A, 6B are integers, we can say A minus 6B by B is a rational, which means that root 2 is a rational, which is a contradiction. This is a rational. A contradiction to the fact that root 2 is irrational. This contradiction is due to our false assumption that 6 plus root 2 is rational. Hence, our assumption was wrong. Therefore, we can say hence 6 plus root 2 is irrational. Thank you for watching. Please like, share and subscribe for more videos.